Hey guys, I'm sorry that I am starting this video very late, very so late. It's been more than a week that I last posted. I've been having series of issues, network and electrical. Okay, now let's continue. Today we'll be looking at sequences. Last time we looked at primitives, but today we are going to look at sequences. So we'll discover what sequences are in clarity and how we can be able to make use of it, understand the concept, and move forward. All right. So remember, we'll be using this Clarity Camp website to streamline our learning process. We'll still get in touch with writing bigger codes. For now, we are understanding the concept first. So sequences hold a sequence of data as the name implies. Clarity provides three different kind of sequences: buffer, strings, and list. Basically, what I mean by sequences of data, I'm going to show you with a little bit of illustration. So say for example, we have a box, rectangular box. So this box is holding series of data. In each column here, that's the data. So we can have one here, we can have two, we can have three, four, five, six. Yeah, as much as possible. These are sequence of data. So now, Clarity allows us to be able to hold data, large amount of data in a series of way, right? So let's go ahead and see an example of how this works. So buffers are like hexadecimals. Hexadecimals are kind of a numbering system that starts from 0 and ends in F. So 0 to 9, A to F. Yeah. I wouldn't want to bore you with the logics of understanding buffers, but just know that buffers represent a certain kind of data. For example, if we copy this thing here, this bunch of character here, maybe you can click on this link here. We'll go to this website, just paste it. Let's see what the out. Oh no, that's not what I wanted to copy. Should click the copy. Still not copying it, so I have to just select. I think that copy button is not working. I have to select copy and then head over here and paste. So if we kind of like click on convert, we see that we get hello. So that bunch of character represents hello. So basically, don't bother yourself trying to understand what buffer is, but just know that buffer is a way to hash a data. If you want to hash a data, buffer does that. So let's move on to strings. Strings is something you may quite understand. String is a sequence of character. Remember, a sequence of something that goes in a sequence. Um, yeah, something that is stored in within columns is a sequence. That is what I wanted to say. So something that you store in a linear format. So a character, if you want to write a word, something like hello, right? Something like this, it goes in a sequence from left to right, right? So now we can count the number of characters in this. HELLO. These are up to 5 characters. So a string is a sequence of character. These can be defined as ASCII strings or UTF-8. What is ASCII? What is UTF-8? ASCII characters are characters that don't like they are the normal characters you have on your keyboard. They don't include emoji. So if you try to send a message that has an emoji with it, ASCII character is not going to accept it. But UTF-8 can accept emojis, anything. So ASCII strings may only contain basic Latin characters. So just like I said, any key you see on your keyboard, yeah, ASCII character can be able to contain it. While UTF-8 string can contain fun stuff like emoji. Both strings are enclosed in double quotes. So these double quotes around here are what you use to note that this is a string. Okay, so but UTF-8 strings are also prefixed by a U. So if you want to demarcate between a UTF-8 string and a normal ASCII string, UTF-8 string will have U starting here. So if we run this, you see that it comes back with the U. But if we remove this, yeah. So if you remove any of these quotes, let's see what happens. It's going to give us an error. So which means for you to declare a string, you have to put double quotes around it. What about single quotes? We can check if single quotes works. There's no harm in trial. You are not breaking the system. So I definitely believe that it's not going to work because Clarity only accepts double quotes around a string. Okay, so we get it back to normal. So this is an example of UTF-8. So you can't take this character right here. This character may be representing an emoji. We don't really know, but it's a way to represent a foreign character that is not a Latin. So if we paste it here, it's going to give us an error. But notice that here we have U in front of it. So when we run this, we're definitely going to get something back. But notice that it came back with extra words, extra characters behind it. It has processed it, it has predefined it, and gave you whatever thing. But we don't really need to bother about how UTF-8 works. So that's basically just it. Sorry guys, I was cut off a bit. So I was talking about list sequence of data. Remember we have different data types. In the primitive sections we talked about uint, strings, and all whatnot. But here list can contain a list of data types, right? Now the data type must be the same. If you're putting in a number on the list, it has to be a pure number, right? If you're putting in, you start with u u integer. When you try to run this, it's going to give us an error, right? Expecting expression of type uint, which means you started with uint, it is expecting the rest of it to be uint. But if you start with an integer and go back here and put u, it will tell you expecting expression of type integer whilst you're putting in u8 behind. So every digit that you put or any kind of character that you put there, any kind of data type that you put there, make sure that the rest of it are the same. So if you put a string, let me say hello here, it is expecting that the rest of it is going to be a string. If you put a UTF-8 string, oh, let me put that back again. Let me just put a string and then I run this. You see, it's expecting the rest to be a UTF-8. So as simple as that. Now let's try to understand how list really works. Imagine list, imagine list to be a column like this. This column that I strike through, right? I mean this uh, tiny box here. So it's a sequence of data, which means you go into each data, you put in a number or you put in a character. Each data has a character. So now everything here has an index. Computer starts counting from zero. So if you want to get the first index, there's the 0, 1, 2, 3, 4, 5. But the length of these characters, the length of this list is actually 6. So the total length is 6, but how computer count is starting from 0. So that is the basics of understanding what a list is. Now let's go deeper and see how we can express ourselves more with this list. I'm going to remove this and run this code. Everything works. So notice that this is appended with a list at the front. Not is it appended or prefixed? Yes. So as you can see, a list is constructed using list function. That list in here is a function. Here is a list of ASCII strings. So like I said, if you are dealing with strings, you only get strings. Don't add any number um, within your list of strings. It's not going to work. So here, this guy is definitely going to fail. Like I said before, if you started with UTF-8, if you started with a uint, finish off with a uint. These are different data types, and It doesn't clarity doesn't accept that. Is a no is a negative. So lists are very useful and makes it a lot easier to perform actions in bulk. So let's say you have series of stacks wallet addresses you want to send money to. Let's say 5,000 STX to each of the stacks, right? Let's say you have 1,000 of them. You don't want to kind of like be sending money one by one to them. You want to store them in a list and then iterate over it and then send money at once to every one of them. So now let's see for the example of how we can manipulate this list. Um, so let's look at map and fold. Uh, so you can iterate over a list using the map or fold. Uh, Map applies an input functions to each element and returns a new list with the updated value. So let's see, for example, we have this list of data. What map will do for us is map is going to use this not statement here and then convert and find the opposite of this, of each character, of each data in this list. So everything that is true is going to turn to false. Everything that is false is going to turn to true. Map takes uh, a not statement and then uses it to pre-process the list and convert everything within that list to its negative value. So not true is false, not false is true. When we run this code, they say that it takes every true within this and converts it to false. It takes every false and converts it to true. So as simple as that. Now let's look at how fold works. Fold works in a very, very mysterious way. I'm going to leave you guys to do the quiz because the quiz is kind of like, um, oh god, what? Okay, so fold applies an input functions to each element in the list. So now fold works in a very, very mysterious way, and it's very confusing. If you're a starter, I spent quite 2 days understanding how fold works. So you may think that once you understand it here, it's the example that they gave here is quite straightforward and simple, right? But once you start doing something more complex, like doing minus or division or plus or multiplication, you'll quickly see that this fold is a very, very complex stuff. So I will teach you guys how it really works. You have to do the quiz and make sure that you get it right. Any questions you have, throw it in the YouTube comment. All right, let's go ahead to understand how fold works. First of all, I'm going to run this code before explaining anything about fold. So now we get an answer U6. Now, take for example, what fold did for us was to add everything in this and reduce it to a single value. U1 plus U2 is going to be U3, U3 plus U3 is going to be U6, but that is not really how fold works. If you think it in a sense, um, fold is going to do something like this. U1, U1 plus U0 is going to be U1, right? Then it takes that U1 and say U2 plus U1 and not U1 plus U2. So let's change this to minus and give you a clear example. Let's say 1 minus 0 is 1, and you now say 1 minus 2 is minus 1. 1 minus 1 minus 3 is going to be uh, what's it going to be? Minus 4, right? So you may think that the answer is minus 4, but that will shock you. When we run this code, what you get is U2. Fold is very, very complex. Now, what is happening here is that it's going to do U1 minus U0. It will give us what? U1. It will now take U2 and do U2 minus U1 and not U1 minus U2. So it's going to be U2 minus U1, which is going to give us U1. And then U1 minus, U3 minus U1, which is going to give us U2. So your operation comes this way. You take, when it is, where's my answer? I put a comment here. So first of all, we do U1 minus, the first u0. Let me increase. Okay, u1 minus u0, right? We do this item in the first list minus this item outside. So you must calculate this with the first one outside. And then we go ahead to, what's the final answer here? We get u1. Then we go down here and say u2 minus the answer that we got after calculating u1 minus u0, which is u1. And then our answer still is u1. Then we go down again and say u3 minus the final answer we got from our last calculation, u1. The answer remains u2. So it's as simple as that and as confusing as that. So everything in this list comes first in the operation. So each one you calculate, after making your calculations, you keep it last. You always bring it last. So u1 minus u0, u2 minus u1. U1 was the final answer we got after the calculation that we made with u1 and u0. So, not to confuse you really, and why is this u0 here? Well, you should ask clarity. Clarity allows you to kind of like, let's say you want to calculate a series of number, you want to sum them up, and then you want to have an initial value. You can even increase this to u2 or any number. So if you don't want to have an initial value, just put a u0 here, and then it will just ignore this guy and then do the operation you want it to do with the rest, right? So it's just for an initial value. You can you can read this. I'm not going to read this guy. You can read them to really understand how clarity is doing their thing. Stop selecting. Oh God. Good. Okay. Now let's look at this. This is quite complex and crazy to read. So now in clarity, if you are to perform any calculations in clarity, start with the last inner bracket. The last inner bracket. These guys before you move outside and then to the, yeah. So u1 plus u0 is u1. Now u2 plus u1 is u3. U3 plus u3. I mean this u3 plus the final answer is u6. So what answer we get here is u6. So start with the inner bracket. The operations are always in the front. So if you're watching this video for the first time, I would want you to go back to my primitive video. The primitives, I explained about this plus of a thing being at the left side instead of the middle, the traditional way of doing 1 plus 2. So you can watch that video. All right. So working with a sequence. So remember, this translates to a a length of actual word. So this is hello exclamation mark. So if you get the length of it, what will we get? Are we going to get the length of this exactly, or the length of um, the length of the actual word? When we write this, what we get is u6 because hello. Remember, hello looks like this. The answer we got when we pasted this thing in the whatever browser here, yeah, this is what we got. So if you count it, h1, e2, l3, l4, o5, then this exclamation mark 6. So the length of this total character is 6. Remember, if you are getting the index of it, h is 0. Getting the index and letter, two different things. But pretend I didn't say anything concerning index. We'll still get to that. So what is the length of this? So you have to count this length. I'm not going to count it. Leave it as an assignment for you. I'm going to run it and get just the answer, 24. So it means that there are total of 24 characters inside of this selected string. Total of 24 characters. So that's basically it. And then the length of this list. This is 1, 2, 3, 4, 5, 6. Yeah. we get 6. So you can find the length of a list, you can find the length of a string, you can find the length of a buffer. Exactly. So they also allow you to extract elements at a particular index. The following takes the fourth element from the list. So remember, like I said, index, computer starts counting from 0 and not 1. So if you want to get an element by its position in a sequence, you start counting from 0. The first element here is 0, the second element here is 2, 1, 2, and then 3. So the fourth element is actually the third index. The first element is the zeroth index. So now we are told to get the element at U3 from this list. Clarity is kind of like crazy. Why is this U3 at the back instead of the front? It's crazy. But anyway, how you do it is this is U3, you start counting 0, 1, 2, 3. So the answer here should definitely be 16. But why are we having sum 16? Pretend you don't see that sum, but I know you saw it. We'll still get to understand what sum is all about. So what if we change this from U to just 3? This is actually crazy. It's going to give us an error, which means for us to get any index, we should use U. Yeah, I don't know why it's that way. Go and ask Clarity. We'll leave it like that. Just so that it's if we want to get anything, we use U3 or U whatever. So let's say we want to get the final element. Let's say U9. There is no U9, but what do we get if we try to get U9? We get none. Why? Because there is no. This ends at U1, U0, U1, U2, U3, U4, U5. So from U6 and above, there is nothing. So it's going to return none. So if we do U6 here, we still get none. But if we do U5, we get the last element. U5 is sum 42, which is the last element here. As busy easy. Alright, so you can also do the reverse and find the index of a particular item in a sequence. We can search the list to see if it contains the value 23. So let's say we want to check whether there is a 23 here and which index does it exist in. In the last one, we're trying to get the element at a particular index, but here we're trying to get the index of a particular element, the opposite. So we're checking if 23 exists within this. Yeah, 23 exists in 0, 1, 2, 3, 4. So it exists in U4. Yeah, but we still get some U4. What if we try to get 29? Is there 29 in the list? There is no 29. So what do we get? You guessed it right. None. Exactly. So we'll still get to understand what sum and none is really all about. So, and we get some UFO indicating there is a value of 23 at the index 4. The attentive, you might now be wondering what is the sum? Yeah, I said forget about it. I know most of you won't even dare forget about it. Okay, read on and all will be revealed in the next section. So, in my next video, we'll be looking deep into optionals. So, this is called optionals. We'll understand why it is that way, why we have some and why we have none, and how we can just get the value for alone without having a sum. Yeah. So see you in my next video.